Once the active sites on actin have been exposed, the next important step of muscle contraction is the cross-bridge cycle. During each cross-bridge cycle, the myosin heads bind to actin filaments, pull on them, and then detach. Now let's examine the individual steps of this cycle. First, the myosin head splits a molecule of ATP that has previously bound to it into ADP and a phosphate. It uses the energy released to assume a cocked position, much like a loaded spring. All of this actually happens before the active sites on actin are exposed, so once they are available, the now cocked myosin heads are ready to bind to them. Next, a cocked myosin head binds to an active site on actin, forming a structure known as a cross-bridge. Note that ADP and phosphate are still attached to the myosin head at this point. As the ADP and phosphate detach from the myosin head, the energy stored in the cocked head is released. As it relaxes, the myosin head pivots and pulls on actin. This movement is known as the power stroke. After the power stroke is complete, a new ATP molecule binds to the myosin head and causes it to let go of actin. Note that as the myosin heads detach, the actin does not slide back. This is because other myosin heads are bound to actin and are undergoing power strokes. To summarize, a muscle contraction is simply a succession of cross-bridge cycles. For an average muscle contraction, the cycle will repeat about 20 to 40 times in each sarcomere of the myofibril. At any given time during a contraction, some of the myosin heads are pulling on actin while others are detaching and being reactivated by ATP. The myosin heads work much like a team pulling on a rope. As the actin filaments slide toward the M line and the sarcomere shortens, the entire muscle shortens and generates tension.